Hello, hi everyone. Welcome to the Student Brand. So today we are going to discuss about electric current, current electricity. So grade 12 and JEE and NEET students can attend and listen to the class. Okay. So generally same topic is there in grade 10 CBSE grade 10 physics electric current. So in grade 12 current electricity. Okay, so here some topics will be extended. Okay, so extension will be there along with the topics of grade 10. Okay, so little more depth will be there. Now we will discuss about grade 12 current electricity, that is nothing but electric current. So now you can see electric current, electric current. Okay, so I equal to Q by T, I equal to delta Q by delta T, and I equal to Q by T. So here normally conductor is there, so charge is moving, charge is flowing. So this is called instantaneous current and this is called average current. Instantaneous current and average current. So what is the meaning of instantaneous current? What is the meaning of instantaneous current and what is the meaning of average current? Oh, instantaneous current. Okay, so we are discussing about instantaneous current is nothing but the current at particular instant. The current at particular instant. So if you are taking the object like speed of light, velocity of the object and acceleration of the object at particular instant, what is the velocity of the object at particular okay, so situation at particular instant, velocity of the object, speed of the object and acceleration of the object, like that we are discussing, right? So here also at the particular instant, so the charge, the flow of charge is called electric current. That is nothing but instantaneous current. So coming to average current. So the total net charge flowing through unit cross section area per unit time. Okay, so then we can say that is called average current. So that is I equal to Q by T. So I equal to delta Q by delta T is instantaneous current. Instantaneous current. Okay, and here average current. And so the flow of charge can be obtained by multiplying direct current, constant current with time delta T. So I'm taking delta T. Okay. Second one, the flow of charge can be obtained. So if you are taking current in the function of time, so T initial and T final, that is I dt. And coming to the third one, so the flow of charge can be obtained by the area under IT graph. Okay. So that's enough. So just check once. So I equal to delta Q by delta T, that is instantaneous current, so average current. So the flow of charge can be obtained by multiplying current in the time, and so delta Q. So charge flow is obtained if current is a function of time, I into dt, and so the flow of charge can be obtained by the area under the graph it. So this is about current, and based on the magnitude and direction. Based on the magnitude and direction, current can be divided into two parts. Based on the magnitude, current can be divided into two parts. Direct current, alternative current, direct current, alternative current. Magnitude and direction. Based on the magnitude and direction, current can be divided into two parts. Okay, so one is direct current, second one is alternative current. Alternative current, that is AC. Direct current is DC. Best example for direct current, cell, battery, and DC dynamo. Coming to alternate current, AC dynamo. Okay. So based on magnitude and direction, current can be divided into two parts. So direct current, cell, battery, DC dynamo, alternate current, AC dynamo. Okay. So these are the examples. So if the charge is moving in a closed path, so I'm taking like here, charge is moving in a closed path, like here. So Q, so with the frequency F, so I equal to QF. Once again, the flow of charge is moving in closed path with the frequency F, I equal to QF. Understood? Next one. Next one we will discuss about drift velocity and relaxation time. So what is a drift velocity? Okay, so drift velocity and relaxation time. Drift velocity and relaxation time. Drift velocity and relaxation time. Relaxation time. Okay, so here I'm taking the cylindrical conductor. Okay, now current is flowing in the conductor, so current I'm taking I. So electrical field will be there. So opposite to the electrons are moving. So opposite to the field, electrons are moving. If the electrons are moving in the conductor, it experience force. So if electrons are moving in the conductor, it experience force. Okay. So there is a drift to velocity. So that is nothing but F equal to E into E. F equal to E into Q. Or Q into E, sorry. Q into E. So electrical field only, right? So Q into E. Then so we can take, F equal to MA. So we know that force equal to mass into acceleration. So now F equal to MA. So MA into Q into E. Then A equal to QE by M. Okay. So that is the acceleration. Okay, I hope it is very clear. Now we will discuss about drift to velocity. Drift to velocity is nothing but, so here, so inside of the conductor, the electrons are moving. Electrons are moving like here and here. They are moving in a different directions. Okay, so like this and like this and like this. Okay, so here they are moving the different directions. What happens when, so anyway electrons are moving in the conductor, so in a closed conductor. So what happens, they are moving in a closed conductor in one directions. So one electron will hit another electron. So actually so one electron is moving with 20 meter per second, suppose just example. Another electron is 30 meter per second, another electron 40 meter, like this. So centimeter or millimeter, so anything we can take. So it is moving with a certain speed. So next one is moving with a certain speed or a certain velocity, and another one is moving with a certain velocity. What happens? So after, so immediately they are moving in a one direction. They are moving in one direction in a closed conductor. Okay. So one electron will hit another electron. That electron will hit another electron. That electron will hit another electron. So keep on collision is taking place. Keep on collision is taking place. After colliding, so electron velocity changes. Initially it has certain velocity. After collision, so their velocity will be changing, or sometimes exchanging will be there. At the same time, sometimes it decreases, velocity decreases, so it exchanges. So this velocity will be given to another electron that is moving with a different velocity. So when it is after colliding, that will move with a little more velocity. After that, that electron will hit another electron, like that. So keep on bombardment takes place, keep on collision takes place in the conductor. So the average velocity of an electron moving in the conductor is called drift velocity. Drift velocity is nothing but average velocity of an electron moving. Average we have to take. Okay, so what happens? So one is moving with a different velocity. After collision, another one is moving with a different velocity. After that, one more collision. So like that, keep on changing, velocity changing. So the average velocity of an electron moving in the conductor is called drift velocity. Is called drift velocity. Coming to the relaxation time. What is the relaxation time? So we know the drift velocity. So electrons are moving with a different velocity in a conductor. After collision, it will changes. Okay, so it keep on changes. Then there is a time gap between the one collision to another collision. Okay, so we know that collision takes place because electrons are moving in a closed conductor. They are moving in one direction, so side by side they are moving, so collision will takes place, right? So one collision will takes place, immediately it goes to the another collision. Okay, so again it will hit another electron, definitely it will hit another electron. So there is a time gap. Okay, immediately it won't hit, right? It will take certain time. After collision, it will take certain time to reach the next collision. Okay, or going to the next collision. So the average time gap between the two successive collisions. See, so all collisions will not take place at equal interval, right? So it will takes place. It will takes place randomly. Okay, at the same time, so more frequently if velocity increases, automatically more frequently it takes place. So keep on bombardment takes place. That too immediately it won't happen. It will take certain time between one collision to another collision, between one collision to another collision. So there is an average time gap between the two successive collisions is known as relaxation time. Is known as relaxation time. I hope it is very clear, right? Understood? So that is about drift velocity and relaxation time. Drift velocity and relaxation time. So next one, we are going to discuss about current and drift velocity. Current and drift velocity. Current and drift velocity. current and drift velocity. So here this is the cylindrical conductor. Area of the cross section is A. Area of the cross section is A. So I am taking A here, and this also area of the cross section A. A. Okay, so this length I am taking here. This is the L, and so current is moving like this. Electrical field will be there. So drift velocity is there opposite to the electrical field. Now, so length we know. Now we can take up and the time also from here to here I am taking. That is velocity. Velocity equal to L by T. Sorry, L by T. Displacement by time taken. So L by T. Now here drift velocity is equal to L by delta T. So length of the conductor is equal to Vd into delta T. Delta T. So now we know the volume. Okay. So volume of the conductor is volume equal to, so length into area. Volume equal to length into area. So volume equal to volume. So I am writing because we'll get confused between V and Vd. So volume equal to length is nothing but V delta T into A. Vd into delta T into A. So number of electrons are present in the particular volume. Okay, in this volume, how many electrons are present? So that we will discuss now. That is number of electrons. Number of electrons present in the particular volume. So that is, so you can observe now N into Vd into delta T into A. So we know quantization of charge. Q equal to Ne. Q equal to Ne. So Q I am taking. Q equal to Ne. Okay. So now Q equal to N is nothing but N V delta T into A into E. So that is charge. Now we know current. I equal to delta Q by delta T. I equal to delta Q by delta T. So delta Q is nothing but N Vd delta T into A into E by delta T. So here delta T get cancelled. Delta T get cancelled. The remaining values are, so I equal to N E V D into A. So we know current density. Current density J equal to I by A. Current density. So current density J equal to I by A. I by A. So now current density. So J equal to what is I? N E V D A by A. So A get cancelled. Then J equal to N E V D. So there is a current density. Okay. So I hope it is very clear. Just check once. Okay. So this is about current and drift velocity. Now we will discuss about resistance. Resistance. Now we will discuss about resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is the device which is used to oppose the electric current. Resistor Resistor is a device which is used to oppose electric current. So what is resistance? Resistance is nothing but phenomena of opposing the electric current in the circuit, that is known as resistance. Resistor is a device which is used to oppose the electric current in the circuit. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. Now you can see here. So resistance R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R equal to rho into L by A. So rho is the resistivity. Rho is the resistivity. You can see here. Resistivity. Rho is resistivity. R is the resistance. Okay, resistance. Now rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. So rho equal to R means ohm. Area is meter square by meter. So meter get cancel, ohm meter. So resistivity is equal to ohm meter. So that's the answer. So SI unit of resistivity is very important. SI unit of resistivity is ohm meter. Ohm meter. Okay. Now we'll discuss about one more. So now we'll discuss about difference between resistance and resistivity. Resistance and here resistivity. So resistance, first point R equal to rho into L by A. Here rho equal to RA by L. And here second one is SI unit of resistance is ohm. Here SI unit of resistivity is ohm meter. Okay. So now here. So third one, resistance depends on length of the conductor, area of the cross section. Depends. And here, so resistivity does not depend on length of the conductor. Does not depend. Does not depend on length and area of the cross section. So resistance depends on temperature, and here resistivity also depend on temperature. And coming to fifth one, so resistance depends on material of the conductor. Material of the conductor here. So resistivity depends on material also. Material of the conductor. Okay, it is very clear. Understood? So check once. So resistance R equal to rho into L by A. So SI unit of resistance is ohm. And here ohm meter. Okay. So this is about difference between resistance and resistivity. Next one, temperature dependence of resistance. Temperature dependence of resistance. Okay, now temperature dependence of resistance, temperature dependence of resistance, dependence of resistance. Okay, so we know that R is directly proportional to length of the conductor, R is inversely proportional to area of the cross section. Okay, so now we can take, so point number one, if temperature increases, initially what happens? So movement of the free electrons increases, velocity of the free electrons increases. Understood? So electrons will move with more frequently, with greater amplitude. So immediately they will start moving. Okay, so with a greater amplitude. So in that case, at that particular instant, so resistivity and resistance decreases. Resistivity and resistance decreases. So conductivity increases. Conductivity increases at that particular instant. Okay, point number one. So we know that drift velocity. Okay. So what happens if velocity of electrons increases? So they will move with greater amplitude. Then automatically, so electron will collide with another electron. Then keep on bombardment takes place. More frequently collisions takes place. More frequently collisions takes place. That time what happens? So then resistance and resistivity increases. By that conductivity decreases. Resistance and resistivity increases. By that conductivity decreases. Understood? These 2 points will takes place immediately as temperature increases. So final conclusion is, as temperature increases, conductivity decreases, resistance and resistivity increases. Okay, so temperature I'm taking here. R is R naught is at T naught. R naught is at T naught. R equal to temperature T. So equal to temperature T. La la la. Na na ne na 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 ne na na na. So R equal to R naught plus R naught into alpha to T minus T naught. Then R minus R naught equal to R naught into alpha into T minus T naught. Alpha is the coefficient of temperature, coefficient of resistance. R minus R naught by R naught into delta T. So here, as R is directly proportional to L, R is inversely proportional to area of the cross section. R equal to rho into L by A. So as temperature increases, length and area of the cross section also changes. So that is very small. That's why R is directly proportional to rho. Then by that we can take the relation. So alpha equal to rho into rho naught by rho naught by, so rho naught into delta T. So that's enough. This is the formula. Temperature dependence of resistance. Next one we will discuss about Ohm's law. So Ohm's law will discuss. So at a constant temperature, the potential difference is directly proportional to current flowing through it. So at a constant temperature and physical conditions also same. So at a constant temperature, the potential difference is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. Okay. So V is directly proportional to I. V equal to IR. V equal to IR. So here I am taking like this. So V on y-axis, I on x-axis. So the graph is linear. For ohmic conductors, the graph is straight line. For ohmic conductors, the graph is straight line. Okay. So at constant temperature, For non-ohmic conductors, the graph is linear. The graph is curved. So V on y-axis, I on x-axis. The graph is curved for non-ohmic conductor. Sir, what is meaning? What is the meaning of ohmic conductors and non-ohmic conductors? Ohmic conductors are nothing but the conductors which obey Ohm's law. Ohmic conductors. Point number one. Coming to the non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. So ohmic conductors are nothing but the conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. For ohmic conductors, the graph is linear. For non-ohmic conductors, the graph is curved. So this is about Ohm's law. And next one, electromotive force. So we'll discuss about electromotive force. Electromotive force. So now you can observe here. So electromotive force. Now you can observe here. So I'm taking the cell here, cell. So connected to resistor. So positive terminal, negative terminal, current is flowing. So when you connect the cell, automatically current will pass. So from high potential to low potential, current will pass from high potential to low potential. Okay, so positive charge will move. At the same time, electrons will move from negative terminal to positive terminal. We know that. But so positive charge should move from negative terminal to positive terminal. Negative terminal to positive terminal in the cell. Okay, so inside of this cell, positive charge should move from negative terminal to positive terminal. The influence make the positive charge should move from negative terminal to positive terminal, or the work done by the battery on positive charge to move from negative terminal to positive terminal is called electromotive force. So EMF E equal to W by Q. E equal to W by Q. Okay, so that is electromotive force. That is nothing but electromotive force. I hope it is very clear, right? Next one, we'll discuss about resistors are connected in series combination and resistors are connected in parallel combination. After that, we will discuss about Kirchhoff's laws. So Kirchhoff's two laws. Now we'll discuss about resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in series combination. Series combination. So resistors are connected in series combination. Okay. So I am taking the resistors 1, 2, 3. So R1, R2 and R3. So across R1, V1 I am connecting potential difference, voltmeter, V2 and V3. So ammeter. So R1, R2, R3. R1, R2, R3. R1, R2, R3. Okay. So we know potential difference V equal to IR. V equal to IR. So here entire the circuit current is same. Entire the so entire the current entire the circuit current is same. So IS equal to I1 equal to I2 equal to I3 equal to I, because all are connected in series combination. All are connected in series combination. So potential difference of Vs equal to V1 plus V2 plus V3. So then we can write in this way, IRS equal to IR1 plus IR2 plus IR3. So IRS equal to, I am taking common R1 plus R2 plus R3. Now I get cancelled. RS equal to R1 plus R1 plus R2 plus R3. So if n number of resistors are connected in series combination, Rs equal to NR. If n number of resistors are connected in series combination, Rs equal to NR. Okay. Now, so we'll discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. So 3 resistors. So I'm connecting parallel combination. So now you can observe current is flowing I. So that is divided into 3 parts. Through R1 I1, through R2 I2, through R3 I3. Now you can take from Ohm's law V equal to IR, V equal to IR, I equal to V by R. So here potential difference is same. Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same. Okay. Now, so Ip equal to I1 plus I2 plus I3. That's enough. V by Rp equal to V by R1 plus V by R2 plus V by R3. Then, so V am taking common 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So V am taking common. So V will get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus. That's enough, no? So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. So if n number of resistors are connected in parallel combination, so Rp equal to n by R, Rp equal to n by R. So yeah, 1 by Rp equal to n by R. So Rp equal to R by n. R by n. So this is the formula. Okay. So just check once. Understood? I hope it is very clear. So next one. So we'll discuss about Kirchhoff's first law and second law. Kirchhoff's first law is nothing but sum of the currents reaching to the. So that is about Kirchhoff's first law. Okay, so now, so Kirchhoff's law, sum of the current reaching to the junction. So the first law of Kirchhoff. Okay, so here current is reaching. So current is reaching and current is leaving. So I1 plus I2, I3 and I4. So I1 plus I2 equal to I3 plus I4. Sum of the current reaching to the junction is equal to sum of the current leaving the junction. The algebraic sum of all the currents reaching at a junction at a point in a closed circuit is equal to 0. So that is nothing but I1 plus I2 equal to I3 plus I4. Okay. Now loop law. So loop law is very important. Loop law. So both are very important. Kirchhoff's first law and second law. So this is about first law. Coming to the second law. So second law you are talking. So second law. So the algebraic sum of all the potential difference in a closed loop is equal to 0. So now you can see here. There are 4 points. Point number 1. So I'm taking the cell. So here current is passing like this. If you are taking the path in this direction, so high potential to low potential means positive terminal to negative terminal. The EMF is negative because the final end to which direction you are moving, to which point you are reaching. So that is you have to take. So EMF is negative. So when you are moving through the cell, okay, so in this direction, negative terminal to positive terminal, the EMF is positive. The EMF is positive. And the next one, coming to the third one, if you are moving through resistor, along the current direction, so the IR term, resistance, this is R and this is the current. So along the direction, so the potential is negative. So IR term is negative, IR is negative. And if you are moving, because here decreasing potential will be there. So when you are moving opposite to the current direction, so current is moving like this, you are moving along this. So this is the path, whatever you are taking, this is the path. Along that direction we are moving. Okay, so positive terminal to negative terminal through the cell, then EMF is negative. So negative terminal to positive terminal, the EMF is positive. So you are moving through the conductor, through the resistor along the current direction, then IR term is negative. Opposite to the current direction, the IR term is positive because increasing potential. Okay, so this is about second law. So we have to apply this all points we have to apply when you are moving in a loop. Okay, so very very important. Make sure that all these points are remembered. Then next. So next one we will discuss about anyway potential difference already completed and heating effect of electric current H equal to I square RT, that is nothing but that is also known as Joule's law of heating. And okay, so that is energy dissipated in the form of heat, H equal to I square RT. So next one we will discuss about grouping of cells. Okay, cell is there, and so when electron is moving, it experience some resistance. Okay, so when electron is moving in the cell, so from negative terminal to positive terminal, so it experience some internal resistance. Okay, charge we can take charge. So electron is moving from negative terminal to positive terminal. So in the conductor, when charge is moving, then automatically it experience some internal resistance. That is internal resistance R we are taking. Okay, so electron is moving in electrolyte we can say electrolyte. Okay, then we can take internal resistance smaller and external resistance R. So grouping of cells. So like resistors are connected in series combination, resistors are connected in parallel combination. Likewise here also we are taking the cells. Cells are connected in series combination, cells are connected in parallel combination. Cells are connected in series combination, cells are connected in parallel combination. Okay, so everything we will discuss now, right? So here you can see. So EMF is, this is the cell, internal resistance, cell, internal resistance, cell, internal resistance. So that is connected to external resistance. So EMF, same EMF, internal resistance, same EMF, internal resistance, same EMF, internal resistance, external resistance we are taking. Okay. Then, so I equal to net EMF by net resistance. Okay. So now net EMF is nothing but NE, because all are connected in series combination. Net resistance is NA and net resistance is NR plus capital R. Okay, so I equal to NE by, so NR plus R. Okay, total net resistance and overall resistance we are adding. Okay, next one. If cells are connected in parallel combination, we'll discuss now. So grouping of cells. Now cells are connected in parallel combination. Now you can observe. So actually here EMF is same. Because all are connected in parallel combination. So net internal resistance, we know R1 by RP equal to N by R, RP equal to R by N. So parallel combination formula. So just now in the previous concept we explained this one. Now I equal to net EMF by, so I equal to net EMF by net resistance. Net EMF is E and R plus R by N. Correct? Yes or no? So net resistance E by R plus NE by R. Okay, so because same EMF, internal resistance is same. So if cells are connected in parallel combination, then formula is this one. If EMF is different, internal resistance are different, then what about resistance? What about current? We'll discuss now. So small change. So E1, E2 and E3 different EMF R1, R2 and R3. Internal resistance is different. Okay. So potential EMF also different. That time what is the formula? That time the formula is, so now EMF. Okay. So now I'm giving this as a homework. Try to do it. So I explained it. Same thing only. So I have to take I equal to net EMF by, because till now I explained it. Net EMF by net resistance. Net resistance we have to find out. Simple only. So we have to apply Kirchhoff's second law. So just now I explained right in the previous concept. So we have to take current is flowing in the same direction. This is the IR term. IR term is negative. So positive EMF. So first equation E1 minus IR1 minus IR equal to 0, equation 1. Next one equation E2 IR2, sorry, internal resistance. Okay, IR2 I2 R2 you can take I1 I2, and this is IR because overall current here same, but here I1 I2 I3 will go, right? I1 I2 and I3 will go. So that's why E is positive, because we are moving from negative terminal to positive terminal. So along the current direction we are going. That's why here IR term is negative. I1 R1 term is negative, I2 R2 term is negative, I3 R3 term also negative, because we are moving along the current direction. Along the current direction we are moving, that's why we are taking. Et equal to I2 R2 minus IR1 equal to second equation. So E3 equal to I3 R3 IR term equal to 0. So that is the third equation. So we need I1 R1 here, so you can take that side. I2 R2 also you can take that side. I3 R3 also you can take all these terms you can take that side. Okay. Then so after getting C1 minus IR1 we are taking common. So after doing all these things, we will get same equation. So what have we got? I equal to net EMF. Net EMF by net resistance. Net resistance. Let me know in the comment section below. Okay, so if you have any doubt, so we will discuss. So it is, I hope it is very easy only. Okay, so I already explained. Just you can take that time. So I1, I2, I3. So we are taking. Okay, so R1, R2, R3. So this term you are taking that side. So try to do it. I need I value. So overall I value we have to find out. I value we have to find out. Okay. So after getting this one, then net EMF by net resistance. Okay. So try to do it. So I'm giving this one as a homework. So thank you so much for joining and attending and listening my class. So if you like the video, if you like the explanation, so do like, share and subscribe to Student the Brand. If you like the content, if you like the channel, you can share to your friends, ask your friends to join to the class. So and CBSE Grade 10 Physics notes is available. So already I given in the description. In the description you can check it. Okay. So link is given. You can check that link and you can check the notes CBSE Grade 10 Physics. And these notes also I'll try to provide. Okay. So electric current. So thank you so much for joining and attending. So this is your Siva sir from Student the Brand. So signing off. Thank you.